With the evolving need for the battery storage technologies, we can expect new and improved chemistry that replacing the lithium ion batteries that are currently dominating the industry. There are a couple of reasons behind this dominance in the lithium ion battery industry. That the first is their much higher energy density than many other type of, which enables their compact packaging. The second is the high life cycle of these batteries. The various commercially available lithium ion batteries that are lithium manganese oxide, lithium iron phosphate, lithium nickel manganese cobalt oxide, and lithium nickel cobalt aluminium oxide. And the last one is lithium titanium oxide. Each of these has its own pros and cons. The important technologies that involved in the development of battery industry, the new form of battery industry that are in terms of energy density, the longevity, and the life cycle. The progress of battery technologies in India, the thermal management is the biggest roadblock, and the weather condition and the temperature that constraint are important aspect that the manufacturers keep in mind. The temperature in India goes as 45 to 50 degrees, but the batteries available today are suitable for only up to 40 degrees centigrade. The high temperature causes the liquid electrolyte between the cathode and anode to expand rapidly. It can make those expansion due to the high temperature and putting those stress on outer casting and making them prone to cracking or even puncture in case of utilities and the functionalities are concerned, and they need to barrier those limit in chemical activity. Extreme heat causes the combustion rapidly. So as the temperature increases further, there is a possibility of explosion or at least degradation of the battery capacity. The electric vehicle batteries must be equipped with those cooling systems, which makes them more expensive. Some important latest designs, such as solid state and the sodium ion batteries, much safer. No separations are required in these and leading to space that have saving and shrinking those battery sizes. Solid state batteries are also have a longer lifespan. There is a huge amount of work that needs to be done to make sure that these batteries are viable for the commercial market. Extensive research is going to develop these graphene and that affirm the situations, and that the hybrid ultra capacitor battery are also being developed, which is used as a supercapacitor for fast charging while maintaining the energy density for the battery. The future of battery technologies in India, the raw material supply is an important parameter for a sustainable battery manufacturing ecosystem. The future of battery ecosystem is basically depends on the raw material, the lifespan, study, research, and India have research and reserves of lithium. They added to which there is a heavy dependency on those inputs for the cobalt and nickel as well. These are the critical raw material for some front runner lithium ion battery system. India is gradually breaking into the sector of mining. The growth in these resources for the battery manufacturing will play a major role in the development of those ecosystem in India. The technology in the past, the demand for batteries will majorly come from the Indo-Pacific region, which has a combination of fast-growing and energy-hungry economies. A lot of countries in this region are looking for those energy security in the long term, and that the adoption of battery technologies and the subsidies driving those policies Both are the supply side and the demand side is involved for the technological advancement in the battery sector and the involvement in the components and the lifespan of this technology that will drive this electronics field in a better way. The automotive industries also require those batteries of high performance at an elevated temperature as well as the high capacity with more range and the life cycle, making the current automobile to make proactive approach toward the research and development of solid state batteries due to continuous electrochemical processes happening inside the battery due to charging and discharging. After a few hundred charge and discharge cycle, the battery internal resistance increases significantly and the battery can no longer be used for applications such as electric vehicles. The biggest consumers of those battery currently are the consumer electronics and the mobility sector. Renewable energy systems are gaining traction to meet those energy demand and lowering those emissions. We need the battery to store that energy and distribute it when it's needed. Talking about the evolution of energy storage equipment and the requirement in this commercial and industrial sector, the economics of using these lithium-ion batteries or advanced lead acid battery for the behind the meter application that does not make much sense. The more reliable and cheaper battery packs is involved and its supply scale that for the next 3-5 years the economics of it could start favoring their uses behind the meter energy storage. There are of course some difference in the vehicle design for a fixed and swappable batteries. In a fixed battery system, the chassis is designed for a fixed battery. And in a vehicle designed for a swappable batteries, the batteries have to be easily removable and must be able to withstand those vibration in a mechanical way. The batteries connect and disconnect very frequently for the swappable batteries, and therefore our connectors have to be designed accordingly. The fast charging infrastructure are also growing rapidly, and there is a decrease in the need of swappable batteries, at least for a private vehicle. But in the commercial space, according to the report, that the affordability perspective, the fast charging technology is not so much in the industry right now, and in practical, there is the uses of vehicle is not so expensive, and it's a fixed battery that could be a better option as the vehicle is charged every night or while in the parking slot. That's all for now. Thanks for your time. See you in the next video.